Hey, welcome to Zona Mechanica. There is an MCQ on rolling of a disc on an inclined plane. Figure at the margin indicates the weightage of the question, that is 2 marks. Two discs A and B with identical mass m and radius r are initially at rest. They roll down from the top of identical inclined planes without slipping. Disk A has all of its mass concentrated at its rim, while disk B has its mass uniformly distributed. At the bottom of the plane, the ratio of velocity of the center of disk A to that of the center of disk B is, there are four options. Option A, root over of 3 by 4. Option B, root over of 3 by 2. Option C 1. Option D, root 2. Well, as you can see in this figure, these are the two discs. This is disk A and disk B. Both are of same mass m and same radius r, and they are rolling down from the top same level. Okay, this is the top level and this is the bottom level. Okay, let the velocity, linear velocity of the disk A at the bottom position be VA, and the related circular motion, that is the angular velocity, be omega A, and that of the disk B be VB, the linear velocity, and omega B be the angular velocity. Sorry, so we have to find out VA by VB. Okay, VA by VB. So this is the question. See, it is told that the disk A has all of its mass concentrated at its rim. So we can consider this disk as a ring, since the masses are concentrated at the rim. So we can consider this as a ring, and this one is uniformly distributed. So we can consider normal disk. So now, from energy balance we can get the expression for velocities. So total energy at this position, at the top position, will be equal to total energy at the bottom position. So at the top position, both the disks are at rest, so only these are having the potential energies, while at the bottom position, when they are touching the bottom surface, so they are having only kinetic energy, no potential energy. Okay, so this height, let this height be h, then the potential energy will be m into g into h. So this will be equal to the kinetic energy here. See, here two types of velocities are there. One is linear motion, that is the linear velocity VA, and the angular velocity omega A. So two parts of the kinetic energy will be half into m into VA square plus half into IA into omega A square. This is due to the circular motion. So where IA is the mass moment of inertia for rim, this is equal to m into r square, and the omega, that is VA by r, so squaring the both, so r square will get cancelled and m will get cancelled from both the sides. So we are having GH is equal to half into VA square plus half into VA square. So that is V square is equal to GH. So V is equal to, VA is equal to root over of GH. Similarly here MGH will be equal to half into M into VB square plus half into M into IB into omega B square. So which implies MGH is equal to half M VB square plus half into M won't be there. Okay, so half I omega square. So here it is a disk. So I for a disk, that is mass moment of inertia for a disk, is M into R square by 2, and this omega is VB by R, so squaring the both. So R square are getting cancelled and M will get cancelled from both the sides. So we have GH is equal to half into VB square plus 1/4 of VB square. So that is GH is equal to 3/4 VB square. So that is VB will be equal to root over of 4/3 G into H. Therefore clearly VA by VB will be equal to root over of GH by 4/3 GH. So that is equal to root over of 3/4. So clearly it's matching with option A. So option A is the correct answer.